polymorphism next to data abstraction is the most important property of object-oriented programming. So let's explain what it is. Well, polymorphism is a word coming from everyday language. It comes from Greek, polymorphism, multiple shapes. And the entity is polymorphic if it can assume different forms or shapes. So, for example, the Greek god Proteus is polymorphic. He is a shapeshifter, able to assume many forms. In computing, polymorphism has a very similar meaning. An operation is polymorphic if it works correctly for arguments of different types. For example, an object message, a particular object message, is polymorphic if many different objects will accept it. And we will see that this is a very important ability, and what it enables is apportioning responsibility. That means each part of the program is responsible for a particular thing, and a given responsibility is not spread out. It's concentrated in one place. And this is what polymorphism lets us do. So, in fact, this is so important that I am calling it the responsibility principle. And polymorphism allows to isolate responsibilities to those parts of the program that are concerned with them and not elsewhere. So responsibility is concentrated in one part of the program. So let's see how this works with an example. So here's a nice example. A patient goes to see a doctor. The patient is sick, wants to get cured. First of all, the patient does not have to know how to get cured. That knowledge is only inside the doctor. So the patient tells the doctor, "Cure me." And the doctor listens, says, "Okay." And he or she does the right thing. Either cures the patient or sends the patient to another doctor, and we assume that eventually this ends up in a doctor that is able to cure the patient. So the message, "Cure me," is polymorphic. It works with all medical specialties. All doctors understand it. And so what this means is that the ability to cure a specific illness is allowed to be concentrated in a single doctor, the doctor whose specialty covers that illness. Okay? So the ability for the message to cover many doctors allows each doctor to become a specialist in one domain, which means the responsibility of curing that illness is only with that doctor. Okay? That's the responsibility principle. So how does that work in programming languages? Well, in fact, all data abstractions we have seen can support polymorphism, both objects and abstract data types. But in fact, it's especially simple for objects. And that's one of the reasons why objects have been so successful. So in this course, I'm only going to talk about object polymorphism. If you want to learn about abstract data type polymorphism, you can look at the book and it goes into much more detail. Now, the idea is very simple for polymorphism with data abstractions. All we have to do is define the interface that a program needs in the abstraction we give it. So then the program can accept all abstractions that have that particular interface. So we automatically get polymorphism. So here's a more concrete example. This is an example where I'm drawing geometric figures. I have many classes, and each class represents a certain geometric figure. So for example, the class circle represents a circle, assuming it's two dimensions with the coordinates of the center and the radius. The class line represents straight line segments with the beginning and ending coordinates. And so each of these classes has a method draw, which draws that figure on the plane. And in particular, we have here a method called compound figure that consists of a figure which has other figures inside it. So for example, if we want to represent a triangle, we can represent it by 3 lines. And the method draw in compound figure can be defined once and for all to work with all compound figures. In fact, it's a loop. It loops for all figures in the attribute fig list, which is a list of component figures, and it invokes the draw message on each of those figures. So it draws all the figures it consists of. So this definition of draw in compound figure works for all possible figures. Circles, lines, other compound figures, and even new figures that we didn't know existed when we wrote compound figure. So we can see that this program is polymorphic. It works for all possible figures. So when is a polymorphic program correct? Because it's very nice to call a program with many different abstractions. We have to make sure that we're doing the right thing for all those abstractions. So the point is that each of the abstractions has to satisfy a certain property, the property that's needed by the program that will invoke it. So for each abstraction, we have to verify that its specification does indeed satisfy that property. And let me just give two examples. For the figure drawing example, it's important that each draw method has to correctly draw the object's figure. And if that's done, then everything is fine. And for the doctor example, a doctor must be able to cure the patient for their own specialty. And if the patient has an illness that's not covered by their specialty, the doctor must be able to send the patient to another doctor better able to cure the illness. We're assuming there's no cycles in this redirection graph, because otherwise the patient will run around looking at doctors and never get cured.